everyone, and welcome to 1337's knowledge stream today. My name is Sarah, and I'm a consultant manager at 1337, and I'm here to bring you some knowledge via our great colleague Anders from the Stockholm office. Hey Anders, how are you doing today?
Hello, Sarah. I'm fine, thank you.
Cool. I'm good too. It's finally turning out to be summer weather, and I cannot be happier about that. I don't know how you feel about that, but I sure have longed for it.
Yes, I have my t-shirt on. Yesterday I had my hoodie, but I couldn't just have it now. It's 19 degrees outside here.
I think we have this about the same here. Yeah, hot. Well, today is my first stream, and I'm super excited to be here for this. Before we start with today's content, we have a lot of knowledge streams scheduled before summer, so make sure to, like, subscribe, and have an eye on our social media for that. Knowledge sharing is very important to us, and these streams are our way of empowering communities during these limited times. And we do look forward to seeing you in person, hopefully quite soon. But, enough from me. We're here for Anders and the topic of DevOps today. So Anders, please take us through your journey.
Thank you, Sarah. Well, I'm excited to be here. It's actually my first live stream as well, so it's kind of awkward to stand here in my home office, but I hope that many of you can see me and hear me, and that you will enjoy the about 45-minute journey that I will talk you through. And the journey is actually a 12-year journey from my previous my previous work at Scania in Södertälje outside Stockholm. So again, Anders Lundsgård, I'm a cloud solutions architect consultant at 1337. But I started here at 1337 this January. So the last couple of 12 years is what this session is going to be all about. And yeah, well, the topic is DevOps, but in general, I want to share some stories and learnings that me and about 150 other colleagues at Scania Connected Services have gained through the journey to be better to deliver software, basically. But we have had DevOps as a buzzword to discuss around for all these years, I would say. Short about myself, my passion in life, or my working life, I must say, is to make developers work much more efficient than I've ever been made myself as a developer. I try to teach now, when I'm into the cloud area since 5 years ago, I try to teach developers how to operate the code in production. But on the other hand, also try to evolve operations guys into the area of how to code their infrastructure. The later has actually turned out to be a little bit more hard to achieve, and I will for sure come into many of those challenges. Since I've been involved in cloud adoption at Scania for about 5 years, and the last 2 years at Cloud Adoption, I for sure will mention cloud, but most of this presentation is more targeting to how to be more efficient as a software developer. Cloud is for sure a good enabler for working in a DevOps way, but the majority is not focusing on cloud. And just a disclaimer before I continue, I will not claim to have a perfect definition of DevOps. There are an Agile manifest that describes Agile, and many have adopted those principles and philosophies. But I would say that DevOps is a very broad term. There are books about DevOps, the Phoenix Project, the DevOps Handbook, and you can name a dozen of them that are really, really good. And those have been inspiring to us at Scania Connected Services. But this is based on my and my colleagues' experience in being better to operate our code that we have developed for over 15 years. Just a little bit about my background. I started after my education in the beginning of 2000. I started at a small startup. And there it was obvious. We were 2 people. Me, I was the only one who could write code. It was me and the CEO. And I started to write code. And it was then very, very obvious that I wrote the code. I wrote the tests. I would want to ship those binaries into the web server. I even were the servers into our server room. And also I would want to deploy my updates to those web servers, and also shipped a fat client to the end users. And I would the one that got complaints from the end users. So for me, it was very obvious that this is the life of a software engineer. For various reasons, I took a step in my career and entered the enterprise of Scania. Instead of having one person checking in code into version control, we were over 1,000 engineers at Scania by that time. But in the area I started, we were 30 developers, and that was shown to be some new challenges, so to speak. But the one thing that I realized that I got to explain to me quite early was that the code you write right now when you came to Scania, those line of code will go into production within 9 months. And that was a total new situation for me. And I thought that, maybe this is how it works in large enterprises. You have longer lead times. So I thought that, maybe that's the case. We have a quality assurance group. After about 1 month, I understand that there's some persons named operations guy, web administrator, database administrator, and so on. And those are to be contacted when you want to ship your code. Again, total new situation for me. And that's what to have high quality in enterprises, you might have these siloed organizations. But I've come to understand during the years that it doesn't have to be the case. The situation I were in back in the garage in the startup, that could also be the reality within an enterprise. This is one of my biggest moments actually from these years. I need to fast forward about to 2015 or something. This is a photo taken from the very last manual release that me and about 10 other engineers went into the office every last Saturday morning every month to do deployment to the production system. And there are a lot of parts in this area that I would today at least consider to be not DevOps. At first, to the left, we have a release plan. In that plan is stated what me and the other engineers into the office this morning were aimed to follow to do a successful production deployment. Some examples of that release plan was that the starting point were take up the phone, call the network administrator, because he needs to do some tweaks in the web UI to take the web service out from the load balancer and redirect the web traffic to a maintenance page. So that was a starting point of the release. And from there on, we had downtime for the end user. Then some steps followed. We made some copy paste of files into these 6 web servers that we have remoted on these screens. Behind me, we had the database administrator that at some point got assigned from me as a release engineer that he or she should start to do the schema updates of the database. And hopefully within 2 or 3 hours, we could be successful deployment and we can bring up the system again. So ending the release with calling the network guy again to remove the switch in the load balancer. In the middle, we have a phone number on small post-it. And that post-it were used, or that phone number were used those time when we got some problem that we, the 10 engineers, couldn't solve by themselves. It was to the engineer manager, because then we had to escalate to get the right people, the developers that were home sleeping this early, get the right person in so we could fix the issue. Luckily, we didn't use that phone number that often, but it happened several times. To the right, we have, this might only be a symbol for that we didn't know actually how long we would be into that weekend. So we had some rebels in backup just to make sure that we could keep working more than 8 hours if necessary. And it happened sometimes that we worked also on Saturdays, and once we actually troubleshoot all day long into Monday. So this was, for me today, a non-DevOps situation. So we have, I guess, many of you interested in DevOps have seen similar pictures. Developers have their own key metrics. They need to deliver more feature and also quicker. Time to market is important. And developers understand that because they have often quite close relationship with the product owner and hopefully also the end user. So they know almost continuously when they're coming in new demands. On the other side of this wall, we have the operations people. On this picture, they are in the same building. At Scania, it took me as a developer to the left. It took me about 20 minutes to walk into the operations center and hopefully be able to talk to the right person who could help me. And I created this picture by the time I had quite a lot of frustration and wanted to express that in some way to the operations guy. So I was the one at the top of this wall. And at some point, I actually have finger pointing to the operations guy. Today, I'm ashamed of it, but there was some time we were stressed because of the push from the market. And I only need to someday only publish a JavaScript file to the production servers. But then I needed a change request, and then the operations guys were there stopping me. So the evolution of DevOps is that we try to tear this wall. The evolution for us was that to get progress in this work, it was actually quite simple. You can think it's simple, but the thing was that we need to talk. We need to meet each other in the workspace and understand each other's challenges in our daily work. And I will come back to that a little bit later. Actually, today, I'm this guy. I work as a cloud security architect, and I've made so for about 2 years. And I have a stop sign in my back pocket. I used it sometimes, but I've made some learnings from my history as a developer. So hopefully can combine so we can work in an agile way, but still having secure solutions. If we step back, before this very final manual release, we made a vision in our department. We made a vision that each and every engineer of us that produces some kind of software via code should be able to wake up in the morning with an idea. At the same day, on his or her own, write some tests for that, and then code a solution, and then eventually, right after lunch, do a production deployment of that code. And of course, and hopefully all ready the same day, maybe the day after, when the monitoring system has gathered some metrics about that change, he or she can evaluate if that change was successful or not. And then iterate from there, of course, taking the decision to roll back it, and so on. What we didn't know back then, when we made this vision, was that was actually going to be reality, not for all engineers at Scania, but for some teams that were in the edge of working in either fashion with continuous integration and so on. This became reality already 2 years after that. I mentioned continuous integration. It's actually one of my favorite topics when you talk about DevOps and the technical part, at least. We made 4 pillars out of what continuous integration were to us. If you Google continuous integration and you look at Wikipedia, you get a ton of them. But for us, these were the key parts. Version everything. So put your code, your test. I think that's very obvious to everyone today, that version control that. Your configuration, your pipeline, how you automate your deployment into production should also be version control so you can track those changes and do safe modifications. The database schema was a part that was the hardest for us technically to solve. Rolling out changes of database schema is a bit tricky compared to just uploading new JavaScript files or similar to a web server. Later, when we started with cloud, we also saw that we could version control the infrastructure. Automation, I think that's obvious. The release plan we had, that was basically our backlog to automate things. So starting at the top, call the network guy, ensure that we get an API. So instead of calling that guy, can have a batch script or whatever to call network load balancer API to bring the service out of the load balancer. That was happened during a collaboration with in an infrastructure architect and integration team. Trunk-based development, or I think today we should say main-based development. Every single engineer on a project, independent of the size, even if I were a startup or were on a monolithic application of 50, developers, everyone should be able to check into mainline at least once a day. So that means no long feature branches. We have been in endless discussions about this. And when we think about it and so see now where we ended up working on mainline, it feels so obvious today, but all the discussions coming to that point and all the improvements that were needed, I can't count hours. There are many. Claim over blame. Now to these lamps in the ceiling. Green is obviously a good color. Yellow is when something bad have happened, a unit test have failed or a production deployment have failed. But green is good in one way because it says that someone has taken responsibility for this change or for this failure. The bad state is red, and the bad state is red after 30 seconds, because if we have something that's being broken and no one takes care of it, then we have a problem. This was a way for us to highlight also for management that what our progress was. Eventually, if the red light were off too much and our key metric points in the wrong direction for that, then maybe our feature teams have too much stress in pushing it now, new features and so on. I need to return to the first bullet, version everything. That's true, except secrets. You as a developer should never put secrets into version control. We can elaborate on that much. I don't have time for that right now, but take that as a key thing. If you have an API key, access keys from the cloud environment or something, never put that in version control. That reveals a lot of some of the obstacles you have to also achieve continuous delivery. Now to some key metrics for us. We measured our deploy frequency. In the beginning, 2011, it wasn't that hard. We had a more waterfall way of working, 2 and 3 projects in parallel, and about 3 deployments to production each year. With the practices of continuous integration that I just mentioned, we achieved to get down to 1 production deployment per month in 2015. But then something happened, 2016. This metric went high up in the roof when we achieved 30 deploys per day. And of course, there were some key things there as well that enabled this. And I highlighted the top 3 here. Once that we splitted up our system into smaller parts. So each team could have 1 single responsibility or eventually a few single responsibilities where they can evolve the code in their own pace. And evolving code does also mean taking care of the deployment into production. So the release team where I belong to just blurred out at that point. I could be a part of a feature team instead of shipping out code for 50 other developers. We can, of course, not have a change management meeting every second Tuesday if we want to deploy new JavaScript or .NET Core files 30 times a day. So we have to challenge those processes and find the new solutions. And one of those improvements were, for example, the network API that I talked about earlier. But also trust and courage from management. We cannot have a senior manager having a bullet in the release plan stating that he or she must approve us to go to production. Of course, we can't have those meetings with 30 deployments per day either. Just to ensure that so far in this journey, we haven't touched cloud at all. So for us, it was possible to do continuous delivery of application changes. It was on a very static infrastructure. We had those 6 web servers that we have to stick with the bottleneck of don't be able to scale that fast and so on. So we were not continuous delivery for everything, but for the application code. And just highlighting our steps regarding one of the pillars in continuous integration, main-based development. From the beginning, we had a lot of feature branches that ended up in well over months, some of them. When we come to continuous integration, we could finally wipe out the feature branches and let every developer push code into mainline. Sadly, by that time, the quality assurance were made of manual processes, so we had a code stop and a release branch. But then, in the end, the branch strategy was quite easy to draw. It was a line on a whiteboard. I guess you can understand that we talked a lot about having teams being self-sufficient and so on. They should be able to push their own code and so on. This illustration shows 2 teams. We were 30 teams, but this shows 2 teams. And I would say among the great things with a team can choose their own tools for CI/CD and frameworks and programming language and so on. For me as a recent engineer, it was so obvious that when things go wrong in this setup, one team gets a problem, like the left one here. The other teams can continue work as usual. In the past, if one team out of 30 got a problem, we had to cancel the whole release and we had to reschedule it. And probably we just made a cross over that release and waited until the next release train. So with this happening in a more modularized system, the team to the right can continue to work. And hopefully they can collaborate. Of course, doing some healthcare on that guy on the floor, but also help to do pull requests if they need to evolve the other team's services because they have dependencies on them. One great thing to achieve is 0 downtime. And basically that means that we don't have to go into to work at Saturday. So that's a good thing, of course. But it means that the end user does not experience any downtime at all. And it enables engineers who write the code to also be at the office the time the code goes live. And that's a good quality assurance metric as well. Because imagine that you as a developer checking code into version control, and you know that in 1 month, there will be some other guys somewhere in this office space that will take care of having this code go live in production. Think about your mindset checking in that code compared to if you have the situation that you check in code and you know that that code will go live in 10 minutes and potentially break the whole system for hundreds, thousands of users. Then you probably, at least I wrote more unit tests. I also much more frequent had a code review, shared knowledge with my colleagues, and I can iterate with small changes continuously. Immutable production, this is, at least the first part of this slide is the favorite one for operations guys, because I state that developers should not log into production servers. And that's perfect for an operations case. Of course, they do not want developers to interfere with the production server. Things always go wrong when developers are interfering with the infrastructure. But then this discussions gets a little bit more complicated. Because I state also that operations guys, you shouldn't log into those production servers either. And that might feel confusing because that's what they do today. That's one of their mission, to do configuration changes and upload certificates or whatever needs to be in place. We should have immutable production because we need to be reliable in how we automate our application development and quality assurance of that. But that also needs to be true for infrastructure. So basically, a configuration change of a Linux server, the Linux server should be reproduced from scratch with that small change. With that kind of pattern, you can easily roll back if something went wrong. But having a system administrator doing a change on a server, mute that state and log out again, it's much harder to understand what are causes issues. We should remove our handovers. I think this is one of the obvious ones to understand. If we sub-optimize within organizational silos, if we would have taken this release plan and looked into all those bullets that we as developers could achieve a lower lead time of, and just forget about that network load balancer manual call, then we would have sub-optimized the process. So try to see the whole value flow and optimize where it makes most sense. And for that, you need to collaborate across the borders. we saw that if we can decouple deploy from release, and this means that the deploy is when we take binaries into the web server or into the application server. That doesn't have to mean that end user experience any change at all. Release is when we enable new features for end user. And that could be made, it could be made frequently, but for us it was more seldom. That might be once a month or once every quarter, depending on how big this release was. But going into production with new binaries on a continuous basis, percent a development team concern. They shouldn't have been able to ask about a change management board or something to deploy in their own JavaScript files. Release, that might need a business decision because it might need to be coordinated with a marketing activity or something like that. This was a big release for us. It was 2016 by the end of it. And this product owner went into the office. This was 9 o'clock in the morning when we had peak time in usage of the system. And he logged into our feature toggle administrative interface and enabled a new Angular front end with a microservice backend for 5 markets. So this was a way for us to granularly ramp up this new architecture for new users. After about 2 weeks or so, we had ramped up for a whole population of users. But this was a very good way for us to see, are the web services doing fine? If there's some issues, which it luckily wasn't, we would easily been able to roll back this release and have the old system live at the side. So I guess you understand that at this point, we started to go into the office at Saturday mornings because we did that basically because we had downtime. But there was one time we got to the bond from the UK market. They, for some reason, wanted a release on a Saturday. It was the 1st of September, so they wanted that. And then this little girl, Tilda, she was 4 back then, she got the responsibility to do that release. And I guess you can imagine she didn't really understand what she were doing. I pointed the mouse to the button and then I said to her, click on the mouse. So this was not an event for her. But you can imagine me standing behind her and having my daughter do the same thing that me and 10 other engineers had gone into for hours into the office space and do several hours and basically achieve the same thing for the end user. When I come this far in the discussions, some questions usually comes up. How do you ensure quality within this ecosystem? And teams can go crazy, deploy code when they want, and so on. And I actually must say that I have no really good answers to that questions. But there were some key things that were a fact for us, and for some reason made the whole system in a much better shape. And of course, as you can guess, we achieved much higher agility with this way of working. We had no acceptance test environment with a known state. So no pre-production environment where we could have QA people going in before a release to production and telling that, yeah, this seems good. We have a stable version. That didn't exist. We favor automated test within individual servers instead of the combination between them. But instead, versioning of APIs is extremely important because what was previously binary dependencies within a monolithic application were new APIs calls over the network. So a team should never introduce a break and change. If you have a break and change, create a new version and deprecate the old one. It's easier to say than be made, I know, but that was very important for make this work. Feature toggling were the things that I already mentioned, that we could toggle features back and forward. The feature toggle was actually one microservice in itself. And that was the only service that we, in the delivery engineering team, the former release team, were responsible of. we saw that was a great tool for developers to use to be able to granularly roll out the features. Monitoring has actually partly been a substitution for traditional manual testing. You have much more confidence to push the deploy button to production if you know that I can look at the screen to the right and see that I have normal flow of a user request and I have HTTP to hundreds and not 500s and so on. Because when you know that you can monitor that, you also dare to push that button because you know if I see 500s on the screen, I can push the rollback. Now to the beauty word affinity. So I said that developers operations guys need to collaborate if we should achieve common goals, basically. And I got to learn myself as a developer that there are things like availability that operations guys cares about. For example, you need 2 web servers because there are things can happen. We can have a power outage in one building and then you need another one. So that is a thing that developer guy or operations guys have taken care for me without me even knowing about it. Durability, scalability, security is something that developers typically in the past at least haven't cared so much about. But within this way of working, we need to take much more responsibility and awareness about security. And those are the things that the development or in a big, large organizations like Scania, there have been disciplines that have taken care of those things and abstracted away from the developers. On the other hand, and I've used this slide times and times again, an operations guy, when he or she got to understand that developers have a really hard time to manage different state of code. And what I mean with that is that developers can have code in production. That's code that is live, that's hopefully bring value to the users in the company. We have continuously new features, new demands. All teams have backlogs that never reach 0 items. So that's code that is going to be produced and needs to be planned for, discussed how the code should be architected and so on. Hopefully, many teams have deleted code, but the hardest state of code are when you have pending code. And that means code that has been checked into version control, but is not yet deployed into production. The longer the lead time from a code change until it goes live in production, the harder. Because then, if you are on a large project, you will have other contributions to the same code base. And then, if you wait 1 month, like we did, we had about 300 changes in one batch out into production. And when things go wrong then, they're much harder to solve. At Scania, we had a cloud-first decision back in 2016. And it was a great thing. It was really, I must say, an enabler for working in a DevOps way, but it was also a very big challenge for the organization. I think many of us know about Netflix, and they have been now the pioneers of going public cloud with all their infrastructure. Already back 2009, they got their cloud-first decision. And this slide at least stated that in the US, the big year for public cloud were 2014. At Scania, we had to wait to 2016 for our cloud-first decision. But that was an extremely big moment for us. Then we finally saw that this is not a shadow of thing to try to deploy things into Azure or into AWS. We also got an agreement globally in the company within the cloud-first strategy that we also could go cloud native. And that means focus in on a very few cloud providers and utilize the services that they make very much management of, and we can offload our operations ourselves. I said that it was a good thing, but it was also a very big shift for us as an organization. Imagine you have a network guy, perhaps not physically moving TP cables when we are doing a release, and having very much manual processes to interfere with the load balancer, and DNS and so forth, different tools. Then suddenly, we see that in a cloud environment, we can start to version control that. Version control that in a way that developers is used to see YAML code, used to use Git, but the operations guys that have the knowledge and awareness of all these techniques for infrastructure, those need to be combined. And for me, that have ordered tons of SSL certificates in the years, when I saw this code, this was actually one of my very first infrastructure as code snippets. And on the few lines at the bottom, with one single line of code, I could import a certificate that was managed by the cloud provider with rotation and so forth. This was a big moment for me. The cloud journey at Scania, we've seen that we need to invest a lot before we gain the values of it. At first, if you have a large enterprise and you have data centers, you have built the skills around specific tooling, there are usually resistance to this kind of change. To offload a lot, to outsource basically the operational infrastructure to another partner, that's quite normal. Everyone doesn't agree on that strategy. There's also legacy. Just having code on a static 6 Windows servers that we had, you can just move them up in the cloud, but you don't really get the benefit of cloud. So having a lot of legacy applications can be a big bottleneck for you to feel that you are gaining all the values of cloud. And also the organization needs to be educated. But when these 3 pillars or these points have been fulfilled, or at least to a certain degree, then the values of cloud raises. Just a sidestep here, as on the last part here, is that I had an honor to be a part of a fantastic team that were gamifying the experience for the truck drivers. To basically, they got a rating each day if they had driven too fast or various kind of metrics. We chose, this was after the cloud first decision, so this was greenfield, and we of course then went on the cloud native strategy. And some warning here, there will be some code. There's no time to dig into the code, but I just want to give the difference from me in the past and within writing this small service. It didn't do that much. It just treated Scania coins, the value that the drivers got from this service. It was written purely on AWS native services, so no need for us as a team to manage it. And just some part of the code. The code itself is not that important, but this is a Git repository. And in version control, we used to have unit tests. Here is some part of the business logic. Here I have the definition of the infrastructure. So now it starts to get more interesting. So this code shows us how we create an API and how we define a compute resource to be able to execute, in this case, our Python code. 3 lines of code, we enable authentication of this API. We can also in the same file define if we want to store some state in a NoSQL database. We have a definition here of a database table. One file for definition of the pipeline. So here this code deploys this Python code into a compute serverless resource into our development account. And here it is being deployed into production. At the very last line there is that we, for this service at least, we had not continuous deployment, but continuous delivery. So we had a manual click of a button to deploy it into production. So taking these 4 files, the upper part is very similar to what we had in the past. We had Python code, we have tests for that. Those code could be executed on a Linux machine, on a Windows machine, and whatever. But the lower parts, we didn't have to order any servers. We didn't need any patching of those or backups. Downtime deployments were built into this cloud managed services, and a bunch of other things that we didn't need to care about. And for me, as a security engineer today, I must say one of at least the biggest benefits of this solution was that we didn't have any secret in this solution at all. No database connection strings and so on. So a very secure solution. I've been a part of the cloud security team for 2 years, and we have come to the conclusion on what core principles should we as a central team of 3 people supporting close to 1,000 developers to make them help them to be secure without having us standing and saying that you should not do this. You should fix this issue and come back when you're ready. Our core principles were 6, but I must state 2 of them that were most important. We as a security professionals, we really get to go out of the cave. And with what I say with that is that if a developer for someday raises some concern that they want help with security, help that guy directly, because then you find affinity. And if you also, when you say no, because you as a security professional should say no, we shouldn't have any wide open server on port 22 for the whole world. That shouldn't be in place. But if that happens, you should have remediation tips to those engineers. We appointed at Scania, appointing 2 persons in each team, typically 7 to 8 people. Two of those have the cloud and security lead roles. And those were the first person of contact when the central team needs to do change, to interfere with them. Finally, if you're a DevOps engineer today, you should not invent an additional silo. You should try to connect developers and operations guys. Sometimes you should be an operations guy helping him or her to understand how to support developers, or vice versa. So this is something that I really try to not reproduce. When a DevOps engineer leaves a company, it should be a state like this. You should learn the guys around you how to develop the code and how to operate it. So when you leave your mission, the team should be able to continue as usual. This is my one page about DevOps. Sadly, my time is running out now, so I have no more time to discuss all the dirty details here. But of course, we should keep distance, at least for a couple of months. But you can collaborate anyway. Do a screen share with an operations guy or vice versa. And eventually someday, we can all try to do the DevOps SAG. So that was my presentation. If you like the pictures and so on, you can reach them via devops.vision. And of course, contact me afterwards. But now I am curious about all the questions, if we have any.
That's so cool. Thank you so much for that, Anders. Just wow. For me, that was super interesting. And I know that we talked about the graphics that you used in this presentation before we went live. And I absolutely understand why you have used them for a long time. They're so brilliant and makes it so easy to understand as well. I really love them. Side note, our poll is now open. So you guys can now cast a vote for Anders as feedback to this session. And of course, we have some questions coming in. I'm just going to open that right up. So yes, you talked about eliminating silos and encouraging collaboration between dev and ops. What are some of the biggest challenges when trying to enable this in a team or organization?
I think that because just the organizational structure is that development team have their own agenda or their own backlog. Operations guys, typically, at least I'm talking, of course, from Scania, there's a network team supporting hundreds of other teams. So when me as a small developer from one of those 100 teams come and want some new requirements, it's hard for me to get into their backlog. So I would say that that's the hardest part. There are our common manager are the CEO, and none of us have ever reached that far up in the hierarchy. So if we want to escalate our issues, that's a hard thing. But to add to that, I must say that for the mechanism I used, or tried to use at least, was to meet those physically meet those people that I know were the ones that could help me. Then, of course, he or she can explain to me that I think this is a good idea, but we cannot do it on our own. And if possible, I could try to support them. But no, so that's a general challenge, I would say, the organizational structure.
Cool. Thank you so much. We have more. We'll just continue. So having talked about the DevOps journey from your perspective, what major developments do you predict for the coming 5 years within this area?
Oh, since I'm coming into my role as a consultant now, I hope to see both areas where teams have achieved much more than we have made. I know for sure that there are. I would like to see large enterprises that do this at scale. The teams that I show here or discussed about, of course, some of the failures, the issues we had, but some are also the edge cases. We had the one team of 3 people, and they were responsible for the very core services, basically the vehicle entity. If those microservices went down, the whole system went down. But that team of 3 people were the ones that were pioneers in doing continuous deployment. So to summarize, I think that doing the same journey as I've made on other companies, that will be something for me to look into. But for those bleeding edge company, like you know the names of them, I think there are always times for improvement. Always times when you can do more of A/B tests to really prove that the things you do. That was something that we at Scania had a lot of things to work around. We always, or most of the time, we went on predictions that we think that the user really wants this, but measure things. I think for me, that is something I would like to experience, to do real A/B testing at scale to prove that we are doing the right thing.
Interesting. We're continuing on with all our questions. We have a coming up here. We are not allowed to use cloud at my current company. Can we do DevOps anyway?
Yes, you can. And I can recall to, if you remember the picture that I have about deploy frequency. So yeah. I maybe not mention that, but doing this 30 deployments per day were actually, for us at least, a DevOps moment when we realized, when we saw that metric, it was very confusing. We didn't think we had measured in the right way, but that was on an on-prem system. Of course, evolving your application needs also to evolve your architecture, and the architecture of your application, a cloud platform, or the capabilities of a cloud platform doesn't have to be a public cloud platform. But anyway, have those capabilities is a good thing. But you can do DevOps on your 2 web service on your desk. I would say yes.
Cool. How many developers have worked on these monoliths at Scania? You mentioned more than 50 per repo. How many in total?
When I started, we were about 20 engineers that produced code into the monolith. When we reached some kind of limit or something similar when we were 60, 70 people on the same code base. We had a measure of 1 release. We were 55 contributors to 1 monthly release. And doing continuous integration with no feature branches, that was already in place. But back then, it felt like we can push more people into this organization, but still having this release planning and so forth. So we didn't get that much out of bringing more people in. And then when we start to talk about this microservice, it was in the microservice era when everyone talked about it. So we, of course, jumped into that hook and started to modularize the system. Something like that.
Something like that. Great. So how do I get started with DevOps as a non-technician?
Read the Phoenix Project. I haven't written it myself, but I read it. It's the only book I have read twice, or 3 times actually. I listened to the audiobook 2 times. That book's it is not a replication of my talk here, but there are many common patterns. And for me, I'm a technician, but for sure that's a lyric, so you can, or a novel, so you can basically read it without any technical knowledge, but to experience and understand the hard parts that engineers suffer from when you are in a large organization, then that is a very good book, I must say.
Yeah.
But then I would say also that we might not have DevOps coaches. I don't know if anyone has that as a title yet. We have agile coaches, so why not have DevOps coaches? But for sure, we could have people that helped organization to be more collaborative and talk across borders. So a DevOps engineer is absolutely not only a person that works with GitLab CI or GitHub Actions. That person also could benefit from having social skills. So you're welcome, Sarah, to join the DevOps team
Well,
here.
Thank you. I consider myself very welcome. Thank you, Anders. Do you think that all developers also have to be cloud developers?
Cloud developers, no, but I think that if teams are aiming for being more agile or work more in DevOps way and working in a DevOps fashion when it comes to also take responsibility for the infrastructure, a team in itself need to have experience or knowledge about how to define the infrastructure in cloud. That doesn't state that each and every engineer needs to have it. But if you see the evolution that we have in the agile movement, that we had code monkeys that wrote code, and we had QA engineers that took the quality assurance of the code, and then we had operations guys. This quality assurance, I think many developers think it's quite normal today to write the tests for the code and takes responsibility for quality. And I think the same evolution is coming into that they also need to have an awareness at least of how this code is going to be operated in production. How is this code going to be scaled if we have 10 users and then peak up to having thousands of users? So I think that if you are a software engineer today, you could definitely benefit in your career to be more aware of how your code operates in a cloud environment.
Cool. You also mentioned DevOps, but I've heard that there are a lot other buzzwords that you mentioned. You mentioned NoOps, you mentioned ShadowOps, etc. Can you elaborate more on those?
And I can start with the hardest one, NoOps, and it's quite fun, I must say. It has two sides. I think at least for me, I've seen both the descriptions. One is NoOps is from operations people when they see that developers get too frustrated, so they take the credit card and go to a cloud provider and wipe it, and they start to deploy the Java code into Google Cloud instead of using the old school on-prem system. And then they blame developers for doing NoOps because they don't know what they're doing, basically. The other part is the more positive side of what NoOps could be. I would say the example that I had of we in the game store that I had in my team, where we chose really managed services. So we chose to use serverless techniques to have no issues with being able to ramp up with more users. So we chose services that the cloud providers took more or less 100% responsibility to operate. If we were to choose a server to operate our code and our API, we had to take responsibility for patching that. So NoOps is two parts. I would say NoOps for me is a good thing, because if we can abstract away the operation thing, because that should only work, then it's a good thing. And then maybe just also the ShadowOps then, because you mentioned it. Yeah. I think that's also quite related to the NoOps. When a team or an organization start to bring up their own version control, because the old version control that is hosted in central IT doesn't fulfill all the requirements, and then they take their own paths. Oh.
Damn, that's some good answers there, Anders. Thank you so much. On that note, that was actually all the questions we had. Some really good questions was in there, and some even better answers on those. Thank you very much. And yeah, thank you so much, Anders, for doing this session. And I'm glad to have joined you in for this. Thank all of you watchers that's been checking in on this knowledge stream, of course. Coming up, next week's session will be about UX design with Lucas de Ritter, who will share his thoughts on design systems, design ops, and their effect on creative critical thinking. And that session won't be hosted by me, but by Mihao. So I would definitely opt you to check that out when that enters the web. So yeah, have a great day, guys. And I hope to see you guys soon. Thank you so much.
The same, Sarah. Thank you.
But just who is Brock? Where did he come from? It is a strange story that begins many years ago. Out together.
The most powerful underground espionage agent in the Western Hemisphere. I've been trying to get my hands on him for years. What's his next move?
But since you ask, I'll give it to you straight.